Hi all, let's see the next topic of multiprocessors, interprocessor arbitration. In today's lecture, we're going to discuss about an introduction to interprocessor arbitration and what are the techniques of interprocessor arbitration, such as static arbitration techniques and dynamic arbitration techniques. So coming to the introduction, what is an interprocessor arbitration? As we know, in a multiprocessor system, there will be multiple processors, main memory, and input output devices which are interconnected by means of a common bus. So what is a bus? A bus is nothing but it provides a communication path for transferring of information between various components that exist in the system. But there is a dispute. Say for example, if one or more processor requests the use of the bus at the same point of time or simultaneously, then only one at a time can use the system bus. So, an appropriate resolving mechanism is required in order to decide which processor should get the control of the bus. Therefore, a mechanism is needed in order to handle multiple requests for the bus. And multiple processors request the use of the bus simultaneously. Then, that particular process which decides to which processor the bus request has to be granted is known as interprocessor arbitration. So the arbitration procedure, it services all the processor requests based on the established priorities of the processors. So there are different types of arbitrations like a static arbitration and dynamic arbitration. Now let us see each and every type of arbitration techniques in detail. The first type of an arbitration technique is a static arbitration technique. So why do we call it as a static arbitration technique? Is in this particular technique, the priorities which are assigned to the processors that are connected to the system, they are static or fixed. The priorities are fixed. So that's why we call it as a static arbitration technique. And it is of two types: serial arbitration and parallel arbitration. Let us see in detail about them. The first type of a technique in a static arbitration is a serial arbitration technique. This technique we can also call it as a daisy chaining arbitration because this technique is obtained from the concept of daisy chaining priority. Did you remember? If you might have remembered, in a priority interrupt, we come across a daisy chaining priority. So, based on that particular technique, this arbitration technique is designed. So, we call this particular technique also as a daisy chaining arbitration. So in this particular type of arbitration, the processors can access the bus based on the priorities assigned to them. So in serial arbitration, the bus access priority resolving is based on serial connection of the processors. So the serial resolving technique is obtained from daisy chaining connection similar to your daisy chaining priority. This is a serial arbitration technique where you have processors connected to the system. They are assigned the priorities based on their position along the priority control line. So this is the first system. This has a high processor having the highest priority. This is the last processor having a lowest priority. So when multiple devices concurrently request the use of the bus, the device with a high priority is granted access to it. So each processor has its own bus arbiter logic with priority in and priority out. PI is the priority in, PO is priority out. The priority out of each arbiter is connected to the priority in of the next low priority arbiter. So the PI of the highest priority unit. This is the highest priority processor. This particular PI, it is maintained at a logic 1. So this will be always at a logic 1. The highest priority unit will always receive the access to the system bus whenever it requests. Let's say the highest priority processor requests for the bus, it will be accessed automatically. But when there is a request from more than one processor at the same point of time to access the bus, so depends upon their priority. Say processor arbiter 2 and arbiter 4 request the use of the bus at the same point of time. Since arbiter 2 is a high priority compared to arbiter 4, this particular processor will be allowed to access the bus, is given access to the bus. So coming to the advantages of the serial arbitration technique, it is very simple to design and we require less number of control lines. There is only one control line required and here to connect these lines. So the number of control lines which are used here are very less. And but coming to the disadvantages of this particular technique, the priority depends upon the physical location of the device. So whichever device is first will be always given a high priority. And the propagation delay due to the serial granting of bus. So because the granting is done in a serial order, there will be a delay in the propagation. Say for example, arbiter 4 request for the bus, this particular signal has to go through all these in order to give the bus grant. So here there is a delay in accessing the bus or getting a grant of the particular bus. That is one more disadvantage. And the other one is the failure of one of the devices may fail the entire system. So if there is any failure in any of the devices connected here, say if there is a failure in this particular processor, the first processor, then it fails the entire system because all are interconnected. So it fails the entire system. And one next disadvantage is you cannot assure the fairness because a low priority device, it might be locked out indefinitely. See, if the processor 1, 2, 3, these are continuously or simultaneously accessing the bus. If at all processor 4 wants to access a bus, it will not get a chance. It might be locked forever. So that is the major disadvantage of serial arbitration technique. So we go for the next type of an arbitration technique, which is a static arbitration, which is a parallel arbitration technique. So here in this technique, it uses an external priority encoder and a decoder. So each bus arbiter, so this is an parallel arbitration technique in which contains bus arbiters, bus arbiter 1, 2, 3, and 4. And each bus arbiter in the parallel scheme, it has a bus request lines. So each bus arbiter has a request line and an acknowledgement line. So when a processor wants to access the system bus, the arbiter of that particular processor, it enables the request line. Say for example, this particular processor wants to access the bus. It will enable this particular request line. And the processor takes the control of this particular bus if this acknowledgement line is enabled. So if you see this diagram, it shows the request lines from 4 arbiters going to a 4 by 2 priority encoder. All the request lines are given as an input to a 4 by 2 priority encoder. And the output of this encoder is a 2-bit code which represents the highest priority among the requesting lines. Say for example, this arbiter 1 and 3 enable the request lines. They are given as an input to the priority encoder. Based on these inputs, the priority encoder will give whichever arbiter is having the highest priority. Obviously, bus 1 is having the arbiter 1 is having the highest priority. That will be given as an output to the 2 by 4 decoder. So that the particular 2 by 4 decoder, it will enable the proper acknowledgement line. So it will enable the acknowledgement line of this particular arbiter 1 since this is the higher priority, right? So it enables a proper acknowledgement line in order to grant the bus access to the high priority unit. So this entire parallel arbitration techniques, it works on the parallel encoded truth table. So it works on priority encoded truth table. So if all the 4 arbiters request for bus, then this particular arbiter 1 is given the chance. If 3 and 4 request for the bus, 3 is given the chance because depends upon the high priority. That particular output is given as that particular is given as an output by a priority encoder which enables the acknowledgement line so that the particular arbiter or the processor can access the bus. Coming to the advantages of a parallel arbitration technique, there are separate pair of bus request and bus grant signals. So it is very fast compared to a serial arbitration technique. In case of a serial arbitration technique, there are common signals for bus request and bus grant between all the processors. So it is a time taking approach. Whereas here to have a separate pair of bus request and bus grant signals for each and every processor. So it is first faster compared to the serial arbitration technique. And coming to the disadvantages, it requires more number of bus request and bus grants control lines. So the number of lines which are connected are more. It makes the thing more complex. So that is a disadvantage. And next, coming to the other type of interprocessor arbitration technique is a dynamic arbitration technique. Till now, we have seen about the static arbitration technique where we come across serial arbitration and parallel arbitration. So these two are static arbitration techniques. These are called as a static because their priorities which are assigned to the processors are fixed. But in case of a dynamic arbitration techniques, the priorities of the system change while the system is in operation. So this particular dynamic priority algorithm, it gives the system the capability for changing the priorities of the devices while the system is in operation. That's why we call this technique as a dynamic arbitration technique. And if you see the types, different types of dynamic arbitration techniques, we have time slice, polling, LRU, and FRU. These four are the dynamic arbitration techniques. Let us see these techniques in detail. The first type of a dynamic arbitration technique is a time slice. So, time slice, as the name implies, this algorithm allocates a fixed length or fixed slice of time to each and every processor in a sequential manner, in a round robin fashion. So, you know what is a round robin fashion? One after another. So, according to a serial manner, a particular time interval is allocated to each processor in order to access the bus. So, this is called time slicing. So the service provided to each processor with this scheme is independent of its location. No matter wherever the particular processor is present in the system, whether it is the first processor or it is the middle one or the last one, no matter what it is, equal interval of time will be allocated to each and every processor in order to access the bus in a round robin manner. So here we are not giving any preference to any particular device or any particular processor because the same amount of time is allocated to each and every processor in order to communicate with the bus. So this is a time slicing technique. Next type of a technique is a polling mechanism. So in a bus system that uses a polling mechanism, the bus grant signal is replaced with a set of lines. So in the previous techniques we have bus request and bus grant. But here in case of polling, we don't have a bus grant signal. It is replaced with a set of lines. We call it as a poll lines and which are connected to all the processors here. And these poll lines are used by the bus controller in order to define an address for each device which is connected to the bus. So the bus controller, it will arrange the address in a sequence in a prescribed manner. So which processor has to access the bus and next which processor gets the bus. So all the addresses of that particular processors will be arranged in a sequential manner in order to access the bus. So when a processor recognizes its address, then it will activate that bus busy line and it will access the bus. So whenever it activates the bus busy line, the other processors which are waiting will not access the bus because it is being used by some other processor. So after some amount of time, the polling process it continues. The next processor will be chosen, so it activates its bus busy line and make use of the bus. So this is how a polling mechanism works. Coming to the third type of dynamic arbitration mechanism is an LRU. LRU stands for least recently used. So this algorithm, it mainly gives a high priority to the requesting device which has not used the bus for the longest period of time. So as we know, the LRU least recently used means we are giving a priority or we are giving the bus to the particular requesting device. If say for example there are two processors which requested for the bus, among say processor 1 and processor 3, among two processor 1 and 3, the third P3 did not use the bus for a longest period of time, then we are going to give a priority to the processor P3 rather than P1 because it is LRU, least recently used. This algorithm implements the concept of LRU. So P3 will be allowed to access the bus rather than P1, even though P1 is the highest priority. We are not considering uh, so the priorities are adjusted after the number of bus cycles according to the LRU algorithm. So after P3 completes it, so you are going to again change the priority of P3 since it has been used recently. So with this procedure, no processor is going to be favored over the other since the priorities are dynamically changed so that in order to give every device an opportunity to access whichever device is waiting for the bus from a longest period of time, that will be given access to the bus. So that all the devices will be treated equally and given equal priority. Next, last type of a dynamic arbitration technique is the FIFO. FIFO stands for first come first serve scheme. So in the first come first serve scheme, the requests are served in the order received. So in order to implement this algorithm, the bus controller, it will establish a queue arranged according to the time the bus request arrives. So whichever bus request arrives, that will be placed in the queue according to the order in which they arrive. And each processor must wait for its turn to use the bus based on the first in first out policy. So that is how whichever request comes first, that will be serviced first. That will be allocated first, will be allocated to that particular processor first. So this is called as a FIFO algorithm. So, coming to the advantages of dynamic arbitration techniques, the priorities can be changed by altering the sequence stored in the controller. So, rather than a static arbitration technique where your priorities are fixed, where some processors are having alloys to priority, they may not get a chance to access it back. In case of a dynamic arbitration technique, you can change the priorities based at the dynamically. So that is one of the major advantage of your dynamic arbitration technique. And this particular technique, arbitration technique is more reliable. And this is about interprocessor arbitration mechanism. Thank you.